Hello ELT132, this is Roger Young, and this is the third video regarding latches. Now the first video we just talked about the operational characteristics of a latch. In the second video, in part 2, we talked about adding steering gates to the latch in which we could enable it. Now finally, in this video, you'll notice that we added this part right here. We got rid of the S and the R inputs. Instead, we just have the D input. And the D input, we spread apart, obviously. One goes to this gate, and the other one is inverted and goes to this gate. Do you recall, well, you might recall, in the first video, we said that we don't want to have S and R both high at the same time. That was the forbidden state. Well, with this kind of circuitry, that's never going to happen, because whatever the input is here, the other input is going to be the opposite. So if you look at this circuit, let's just look at the one up here in the upper left, right? You still have an enable, right? So your D input, by the way, D stands for data. Your D can be of 2 points, right? It can either be 0 or it can be 1. That's the only choice you have, right? And you have your enable. So if this is not enabled, if it's low, right, then no matter what D is, it's not going to propagate through, right? Because these gates have inhibited it from doing that, right? So let's just look at each condition, right? Let's start at A. This is called the no change state. Why do you think it's called the no change state? Because regardless what D is, if it's 0 or if it's 1, your enable is 0. With your enable 0, which means you've disabled these gates, that means nothing's going to go through, right? So whatever Q is now is what it was before. Q naught means when at time t0, that's what that means. And Q is your current time where it is now, all right? So this is your first one. Your second condition is the set condition, right? So that's when D is 1. So your data pulse coming in here is high, right? Look at your output. It's high, right? Q follows D. Remember that for a data latch, right? So if your enable is on, in other words, you've enabled these gates so that the pulses can transmit through, Q will be high, Q naught will be low. This is in the set state, all right? And conversely, as long as you have the chip enabled, your enable pin enable equal to 1, if D is 0, Q will be 0, which means this is in the reset state. And you notice how they have them marked. This is the set condition. When I say they, I'm talking about your textbook. And this is the reset condition. And finally, if you look at a truth table, you can see that if your enable is 0, it doesn't matter what D is, that's what the X refers to, that at QT plus 1, it's going to be what it was at QT. In other words, there's no change. That's what this is saying. But if you have an enable, if D is 0, Q is 0. And if D is 1, Q is 1. So remember that Q follows D. Now, in the next video, we're going to start talking about flip-flops. And with the text that we are using, a flip-flop is defined as when the enable pulse is connected to a clock. All right? So flip-flops and latches are very similar, although they're not exactly alike. And you're going to hear the terms used, and they might be used interchangeably. But how we're going to use them through this course is a latch means that your enable is not connected to a clock, and a flip-flop is connected to a flop. All right, thank you for watching.